All right, so before we get going, the 13th, right, which is Monday, we have those first two assignments too. So there's that Connect assignment and the Excel assignment. I'll be around tomorrow, my office hours, but also if those don't work, send me an email. I can try to set up a time to meet with you. But Friday, I'm pretty unavailable with classes and meetings. So if you're wanting help with that, try to start working on that early. I mean, I guess it wouldn't be early at this point, but start to, try to chip away at that, figure out what questions you want to ask me. Obviously, Monday, you can kind of ask some last minute questions, or over the weekend, if you want to send me some questions, I might not respond right away, but I'll try to answer some of those as well. I'll put up another Learn Smart assignment. I'll probably set that due date to be next Wednesday. We'll start going over some probability stuff next week. So I want you to start having a look at that before we jump into some of that material. So you'll see that pop up there on Canvas this afternoon. The next Learn Smart, which will be due on that Wednesday. Those are, like I said, it's just 5. I wouldn't worry about that until after Monday, honestly. Just get that done between Monday and Wednesday. It'll just be up there a little bit early. The other thing I want to mention before I throw up on Canvas and freak people out, I have some old questions and some old, I don't know, maybe kind of call them like quizzes, just to kind of, if you want to take a look at it and kind of make sure you're kind of following where we're at. So it'll be kind of covering some things that we covered up to basically today. I'll post that in the answer key, just basically some additional resources. It's not worth any points. It won't be an assignment. It'll just show up under the files. I'll label it, sample quiz or something like that. So you'll, be made pretty evident that it's not worth anything. It's just some additional resources. Let me make sure. Oh, I put up an announcement on Canvas as well. That Connect assignment, there's 2 problems. I believe it's 11 and 12. I guess we could check the announcement here. That have a part B, and it's something that we're not going to cover, but it wouldn't let me throw those out. So I put the question there anyway because I like the rest of it. Don't worry about doing those. Once the due date's passed, I'll go back through and basically give everybody credit for that part B on both those questions. Other than that, are there any questions from me before we kind of jump into things? Also, I had someone ask me, and then I somewhat panicked. I was like, hopefully everybody knows. I mean, I've went over this a couple of times, but right at the YouTube page, you can go back to the syllabus. Actually, there's a link to our class's YouTube page, which is where I'm putting all the recordings to the pre-class videos. Specifically, the person asked about this, the Excel assignment stuff. So everything we've done in Excel, I spliced together a video, and that's up on the YouTube page as well. If you don't want to hunt back for the link in the syllabus or anything, just search Professor Lannis on YouTube. I kind of went over that day 1. I'm the first one that pops up, big orange circle with a P in the middle of it. So it's not too hard to find. Click on our sections playlist, and you'll kind of see all the videos there. Okay. If you're having issues finding that, please let me know. I didn't think it was, it's not wildly hard to find, but any questions before we get going? Okay. All right. So pull this up, and then we will jump into kind of pick up where we left off. Look at some examples similar to what we were doing on Friday, but we'll also look at some new material as well. It's going, maybe. All right. So we were talking about weighted means last class. We can do the exact same thing, but do a weighted variance. Right? So if we have weighted means, we're trying to figure out where the middle point of the data is. We also care about how much is the rest of the data, or how much is each group here, right? Because we're working with group data. We're dealing with weighted things. How much does the rest of the groups deviate from that middle point, right? So that would be our weighted variance. Right? How much on average does each group deviate from this middle point? Okay? So it's going to look very similar to what we're doing with the variance, right? So you kind of see there that xi minus mu, right, in the parentheses. That was just take each observation's deviation from the mean, right? Well, now each observation represents a group, but it's the same idea, right? In terms of how the data looks, we're still going to go through the exact same process. So we'll take that deviation squared for each observation. The only added thing that we'll now do is multiply by the weight. Right? So one thing that we'll kind of point out here is we start with the weighted mean, right? Kind of got that n in the denominator. Well, we're looking at the weighted mean. We'll change colors after this. We did what? Well, it doesn't look like a W. W times x, and then we divide it by the sum of the weights. Right? We can think about that sum of the weights really represents the number of observations in the original data, right? We're only seeing the group data. So this was the idea that there's a data set where it has a bunch of thousands of individuals in their income, but the census will only give it to us in groups, right? Well, we know that those weights, right, if they're representing kind of the number of people in each category, right, however we break the income data down. When I add those weights up, that should just be the original number in the data set that I can't see, right? So there's a data set of all these individuals. I can't see it. It's grouped, right? But once I see the group data, I know that every individual was counted once. So when I add those weights up, really I can think about this as n, right? This is kind of the total number of observations in that original data that I can't see, because all I can see is the group data. So it kind of doesn't matter which way we're thinking about this equation, right? How we're thinking about the denominator. You can write it in multiple ways, right? But that denominator is really representing the total number of observations in that original data that we can't see that was then grouped. We'll go through an example here. So we go back, we have that income data broken down by race and gender. I just pulled out the male data just so we can kind of don't have to worry about differences across gender for this. So we've got 4 groups, right? We have the average income of each group. So I basically just created an additional column, right? So what I did is I went through each observation, the 59,000, that's the income for that first group. I subtracted the mean, which I don't have the old slides, but I believe it was like 53,000 or something we came up with last week. So I'll take that mean of 53,000, subtract it from 59,000, square that deviation, and then multiply it by the weight for that group. Now notice that's a huge number. This example would not be a very friendly one for me to put on an exam or something like that. I wouldn't give you an example with incomes because when we're dealing with income, the values are just so large, we're going to end up with some pretty crazy intermediate values when we're calculating this. But this is it's the same process I would use for a more simple data set as well. So once I go ahead and do that deviation squared times the weight for every single observation, I'll then add all those values up and divide by some of my weights here. So it's really like, it's almost like the process we were using for the variance. Throw in a little bit of the weighted mean, right? It's kind of like combining those two to get our, how we would calculate the weighted variance. We'll go through more examples. So I have this slide up there. I just showed you kind of some of the intermediate values for calculating that weighted variance for males. You can do the same thing for the female observations on the right-hand side here. I put that number up, might be a good thing to kind of make sure you could reproduce that number, walk through each observation. If you go back to last week's slides, you can find kind of the average female for the weighted mean, right, for the females, or you could just recreate it on your own. Once you have that weighted mean, go through each observation. So I don't know, let's say it's 30,000, just to make it an easy number for me to say. The weighted mean was 30,000, 34,000 minus 30,000, square that deviation, then multiply it by the weight for that group of 75,000. Write that number down. Go to the next group, 28,000 minus that weighted mean of 30,000, square that deviation, multiply it by the weight for that group, which is about 14,000. Write that number down. Do that for each one of these 4 racial categories. Once you've done that for each category, add them all up, and then divide by the sum of our weights here, right? Just adding up the number of individuals in each group we have. So it's nothing terribly, I don't think, different from what we were doing with the weighted mean or the variance calculations, kind of combining those two. Once again, if you want some more numbers to work through to make sure you can reproduce these weighted variances, I kind of showed you what they would be for that data we had that was broken down by region as well. All right, so kind of I went through a little bit quick, but it's because I've got something also very similar that we'll go through in a little bit more detail, okay? So we have this group data, and sometimes it'll be grouped even more inconveniently, right? If we had the original income data, it's very easy in Excel or something to calculate the mean and then the variance pretty quickly, right? But we don't. We saw a group and still present some problems to us. We might also see group data look something like this, right? So there was an original data set here, which was like, I think this had something to do with like satisfaction rate of customer service or something. And basically, they took that original data, every individual response, and they threw it into this, right? They said there were 4 people who responded with a satisfaction rating somewhere between 36 and 38. There was 15 people who either responded 39, 40, or 41. There was 25 people who responded either 42, 43, 44, right? But they kind of threw it into these bins, okay? So how would we deal with something like this? Well, you kind of imagine we have frequencies here. So it's likely we're going to use those frequencies as what? Calculating weighted means and weighted variances. What would those frequencies probably be a pretty good use for? Our weights, right? We know that that satisfaction rating of 36 to 38, well, that only represents 4 people, while the 42 to 44 represents 25. So if we're calculating the weighted mean or something like that, that middle category is representing way more people. It should carry more weight. Well, how do I weight that? Well, I'll use my frequencies, right? Because that's showing me the proportion of the data that they are, right? So each one of those categories are. So we might think, okay, we'll go through, calculate the weighted mean, take the weight for each group, multiply it by the X value. Great, right? So go to that first observation, take that weight for that frequency of 4, multiply it by, what's my X value? I've got a range. So anytime that you see group data kind of put into these bins, what do you think might be something that just intuitively you might do? There's 4 people. They all responded 36, 37, or 38. You just don't know which one. Value might be used for X there. The middle value, right? The median. Or in this case, what we'll call it, because it's not, the median kind of refers to the middle point of the data. We're looking at a bin. We'll call it just the midpoint, right? But think about it, it's the median. So whatever splits that range exactly in half. So, for instance, we go through the first observation, take that weight of 4, multiply it by 37, the midpoint for that first bin. We would then add to that the next group, take their weight, 15, multiply it by the midpoint of that group, which would be 40. Excuse me. Go on, do this for every single observation, right? We're adding them all up. And then finally, we're doing a weighted mean. We'll divide by the sum of our weights, which would just be adding up these frequencies. So it's going to look a little bit different. Well, I'll ask a question too before I show you the equation. If you were just looking at this data, what would you guess the weighted mean is going to be around? Approximately where would the middle point of this data set be? 43. Yeah, 43, I think 42, 40, somewhere probably in that range, right? Because that's where the majority of the data is. So that value, that midpoint for that bin, right, 43 will carry the most weight. And then, the values to either side of that are pretty equal, right? There's 19 that would be 46, 15 that would represent 40, 4 that represent 37, and 40 that represent. So it's kind of balanced on either side. So probably somewhere in that range. So just before we even start doing a calculation, just like think what we're trying to find, right? We're trying to find the middle point of this data. If I'm looking at it, I mean, logically, it's going to be somewhere between 42 and 44, right? I don't know the exact value without doing the actual math, but if I come up with an answer and it's 63, I know I did something wrong. In fact, anything outside the range of what? 49 to 37, because that's our highest and lowest midpoint here. Well, if we're looking for the middle part of the data, how could it be below the minimum or above the maximum? It doesn't make any sense, right? So we can check ourselves, make sure we're not making egregious errors just by the principles behind what we're doing. So the equation that we're going to have, basically the exact same thing we were doing before, where you've got the weights multiplied by the X value, which is now our weights, our frequencies, doesn't really change anything, just the notation changes. And then we're going to be using the midpoint of each one of these bins. You can imagine, you should be doing for your Excel assignment and what we did in classes, you can create like those, create a histogram, but to do that, right, we first created kind of the frequency chart. So we had all these bins, and then the frequencies, we can find the weighted mean going back to that data as well. In fact, if we have a little bit of time today, maybe we'll do it. Otherwise, I might kind of show you an example on Friday of that. But really, procedurally, nothing's changed. And then, of course, we divide by the sum of the weights. Here, our weights are frequencies, so just the sum of the frequencies. And the sum of those frequencies should just be, right? We talked about this when we were building frequency distributions, and we had that chart with all the frequencies. We said if we add them up, it should be equal to the, we add up all those frequencies after we force the data into bins. The frequencies should always add up to be what? Yeah, the total number of observations or responses in the original data set that I then put in the bins, right? Because that was the idea. When we were creating those bins, we said one property was that had to be exhaustive. Every observation had to be counted only once, but at least once, right? It was in one of the bins. So the sum of those frequencies should be the total number of observations in our original data set. Okay. Any questions on any of this up to this point? We keep moving. I know I didn't kind of write down what we're doing here, but I'm saying it in words. Maybe sometimes if I'm doing this and I'm explaining to you, kind of take 4 and multiply by 37. If that for you doesn't stick, if you're just listening, maybe a good thing is like when I'm talking, write the numbers down, right? And then it kind of creates those, I guess, pathways, right? From writing the 4 down, it kind of gives you something in your notes to go back and look at. It's a little more helpful as well, okay? But really, we're not reinventing the wheel. We worked through a lot of weighted mean examples last week, so it's nothing terribly new. But if we're dealing with sample data, right, and we force this sample data into these bins, right, this group data, we want to calculate the variance. It's going to be very similar to what we were doing. So I'll come back here in a second. It's going to be the exact same thing I was talking about with the weighted variance. It's just now our weights are frequencies and our x values are midpoints, right? But if we're dealing with sample data instead, and we're calculating this weighted variance, we still have that property that the sample variance, we divide by n minus 1. Okay? So what's that going to look like when we're doing this for data that's in bins? Well, the numerator, I'll just kind of rewrite here. So I have frequencies, right? Midpoint, subtract the mean, and square it. So I go through every single observation, take its midpoint, subtract the mean, take that deviation, square it, and then multiply it by the weight, which here is just a frequency. Do that for every observation, add them all up. But now I know that if it's a sample variance, I divide by n minus 1. However, I can't directly see n, right? I don't have the original data, right? The whole reason we're talking about this is the issue is I only have group data. Okay? So this n, this number of observations, where am I going to get that? Well, we set up there, right? What's something else that represents n, the number of observations in that original data we can't see? Well, that's just if we add up all those frequencies. So instead of n minus 1 here in the denominator, for calculating a weighted variance, we could also think about this as, I guess technically, right, the sum of the frequencies here minus 1. Okay? But I'm using kind of this, I'm kind of interchanging the sum of the weights or the sum of the frequencies in n because the idea is pretty crucial, right? When we see the group data, there is some original data set where we could observe that n, that total number of observations. It's just all we have is the group data. Questions on this? I'll show you an example. So, like I said, I put these on the slides like this because I think it's probably the best way to do it by hand. But what we would do is just create a column right next to the original data. For that first observation, take that value, that midpoint of 37. And I would, oh, sorry, I'm showing you the mean first, right? How can we do the weighted variance if we don't have the original weighted mean? All right. So what I did here is I just went through each observation, multiplied that midpoint, 37, by the frequency for that group, 4. So 4 times 37 is 148. Go to the next observation, take the midpoint of 40, multiply by 15, that's 600. Do that for every single observation, and then add those all up. Right? That's where I'm getting that 2,795. I'm just adding up all those products for each group. And then that's our numerator. Then we divide by the total number of observations here. So if I add these frequencies up, I get 65. Right? That's the sum of my weights, or the sum of my frequencies. So sure enough, I get that this weighted mean is 43, right? We kind of guessed ahead of time it's probably somewhere between 42 and 44. I chose these numbers so that we kind of work out, kind of nice and neat, and we get exactly 43. Okay? So I've now got my weighted mean. Right? Now I'm going to go and calculate my weighted variance. So I'm going to use this value, this middle point of the data, which is 43. I'm going to go through every observation. So for the first observation, take the midpoint of 37. Subtract that mean of 43. So it's what? Negative 6. I'm going to square it. So that would give me 36. And then multiply it by the frequency for that group. 4 times 36 ends up being 144. Go to the next observation. Take its midpoint, which is 40. Subtract that mean of 43. Square it. Then multiply it by how many people were in that group? 15. 15 times, 40 minus 43 is negative 3. Squared is 9. Multiply it by the frequency of 15, we get 135. Right? So we go through that, do that for every single observation here. When I say observation, every single row, right? Our observations are groups because all we have is group data. Now notice this middle category, it was a value. That value of 43, that midpoint, was evidence that there's no variation in the data, right? I mean, that one group didn't deviate from the mean at all. So notice the value it adds to the variance is 0. Now, the other 4, right, all provided some evidence that there is variation from this middle point. And notice 46, the midpoint for this group, is what? 3 away from the mean of 43? And it gets weighted by the number of people in that group, 19. Right? So it wasn't very far from the middle point, but there are a lot of people, right? That variation represented a lot more people than some of the other groups. So the value that the bin 45 and 47 adds to the variance is 171. But notice the bin of 48 to 50, that midpoint of 49, that's even further away from the middle part of the data, but it only represents 2 people. So when I take that deviation squared and multiply it by my frequency or my weight here, it actually adds a smaller value for the variance because even though it was evidence of more variation, it only represented 2 as opposed to 19 people. So you can kind of see if you do this by steps, you can kind of, I think, conceptualize, or the conceptual idea of the variance makes a little more sense, right, with these weighted variances. Yes, how far away from that middle point matters, but with the weighted variance, it also matters, well, how many people does that deviation represent? Or how many companies does that deviation represent? Whatever the example happens to be. Usually we use individuals, so I think it's a little bit easier to talk. So once I do that for every observation, add those values all up, I get 522. I'll then divide by what? (65) minus 1, right? Because we were saying we're dealing with kind of this sample data set, right? So divide by 65 minus 1, or 64, and we can get that weighted variance. Any questions over anything I said there, or anything kind of maybe you're just curious about? I don't know. Not curious about weighted variances? I don't think anybody is. So we've got this weighted variance. All the properties kind of still apply, just like the property of finding a sample variance applied to the weighted variance, right? N minus 1. The other properties do as well. So if I have the weighted variance, how would I find the weighted standard deviation? Really trying to hammer this idea home, right? Yeah. So I'll keep saying this, and we'll probably say a lot more throughout the whole course, but we got the variance to get the standard deviation. We simply take the square root, right? So I would take the square root of 8.16, so 2 point something. So same principles kind of apply there. Okay? Oh. Any questions over this weighted variance or weighted mean stuff? We're going to change pace here to a different topic. All right, so let's do percentiles. And this was kind of where I put that pre-class video up. Sometimes I'll ask questions over it, sometimes I won't. Today I'm not going to ask questions over it, although we will have a question I'll probably ask you to do on your own and work through it here in a second. So percentiles, right? I mean, hopefully, I don't know. Well, I guess no, you didn't have to, right? Because it's optional here. But if you've ever taken a standardized test, right? The SAT, ACT, ICEP, I think they let you know. You might have been told something like, you're in the, hopefully you were told you're in the 99th percentile, right? Because what does the 99th percentile mean? If you had to say it in words, if you were in the 99th percentile of a test score, what's that mean? Yeah, right? It doesn't matter how well you did. You could have gotten a 62% on the test or the exam or whatever test it was. But what it's saying is whatever value you got, whatever test score you received, it was better than 99% of the other test scores. So whatever your P percentile you're interested in is, right, the 75th, the 80th, what that's really saying is that value is greater than P percent, right, 75, 90% of the other values, right? Whether that's test score data, you can find the 90th percentile of height, you can find the 90th percentile of income, right? It doesn't matter what the variable is. You're saying that value is better than whatever percentile you're interested in, that much, or it's greater than that percentile of the rest of the data, right? Whatever the P percentile you're interested in, 75th, 90th, 80th. So we're going to have a little bit of work to do to find this. But another way we can think about this is if I'm in the 90th percentile, that also means that I'm worse than 10% of the test scores, right? So I'm greater than 90%, but I'm worse than 100 minus whatever the percentile is, right? So if I'm in the 90th percentile, I'm worse, you know, my score was worse than 10% of the other scores. In the 80th percentile, I was worse than 20% of the other scores. It's not, I think a lot of us have kind of heard this or know this idea of percentiles, but we're just kind of breaking it down here. So you might have seen something like this, right? So the doctors have this, right? Like this is like the most wild chart to me. So you've got different ages, you've got height here, and then they kind of graph, okay, at each age, what would the 5th percentile of height be, 10th percentile, and they kind of have all these lines that represent it. So like, what? When I was 15, 5 foot, 5th percentile height, right? Wasn't a very fun time. But you could find all these different values, right? So how are they creating these lines? How are they determining that at 15, the 5th percentile height, or the height that would be, you know, only above 5% of the other heights? How are they finding that value? So the process by how we're going to calculate percentiles, we're first going to arrange the data, right? So smallest to largest. Right? Like whatever data set you have, let's say I was trying to find the percentile for height in this class. I would take every single one of your heights, I just then arrange them from smallest to largest. Once I have that done, I'm going to use this formula that tells me the position of whatever percentile I'm interested in, right? So if I had, say, 100 observations, right, I might go, you know, I want the, I don't know, 83rd percentile. I'd be kind of around that 83rd position, right? But it's not exactly the 83rd position because we're dealing with sample data. And so that's kind of where this n+1 comes into play. You kind of imagine too, like if I had 10 observations, because I was looking at the 9th position, it now technically wouldn't be greater than 90% because there's only 9 observations left now that I'm taking one of the 10 away. And so it ends up being not quite as intuitive, right? You might think, well, if I have 10 observations, the 90th percentile would be the value in the 9th position. It doesn't quite work out that way. Because as soon as you take out that value in the 9th position, you now don't have 10, you only have 9 observations. So this formula will kind of tell us where the position is of the percentile we want. So if I plug in, you know, if I want the 90th percentile, my value for P would be 90. And then N is just however many observations I've arranged from smallest to largest, right? However many observations were in that data set. If it's an integer, well, my job's pretty easy. Let's say I plug in my values to that formula that tells me the 90th percentile is in, I don't know, the 33rd position or whatever data set I have. Well, it's in the value that's in the 33rd position. I just look at my arranged data. I go to the 33rd position, right? Well, whoever count up to the 33rd position, and that's the value that would be the 90th percentile. It's a little bit more of an issue if it's not integer, right? If I end up with like 33.4, Well, I don't have a 33.4th position. I have a 33rd and a 34th position, but I don't have anything in between the integers. So if I use this formula and I end up with a non-integer, we're going to have to do something called interpolation. And I've kind of hunked on this, but some of the stuff we do later in the course, we actually could do interpolation with that as well. So I think when we get there, I'll probably mention it to you. I won't really necessarily expect you to do it a lot of the time. But understanding what interpolation is will also help us understand why when we're doing certain formulas in Excel, we're getting some of the values that we do kind of for future topics. So I'm going to introduce this idea now. All right, and I'll show you what interpolation is and kind of give you an example. I think that'll make a little more sense. So the first step, hopefully we all can arrange data from smallest to largest, right? That part I think is pretty easy. So if I had some original data set, maybe it was the returns or the value of different metal funds, right? I could put them from smallest to largest. Now, one thing here, I think when it comes like the Connect homework, or we're working through these problems, one easy mistake could be, I have negative values. Remember, larger negative values are smaller. So they would kind of be the first ones. Notice here, negative 56 and then negative 7. So I arrange it from smallest to largest. I've got, what, 10 observations here? And let's say I want the 25th percentile. So what metal fund value will give me the 25th percentile? So the next step was using that formula. Just plugging in my number of observations, which was 10, and whatever percentile I was interested in, which here was 25. So it tells me that the 25th percentile, the value that would be the 25th percentile, is in the 2.75th position. Well, I don't have a 2.75th position. I got a second position and a third position, right? So what I don't want, so I know that the 25th percentile is somewhere between -7 and 8, right? But it's not exactly in the middle because 2.75 is a little bit closer to the third position than it is the second, right? So essentially what I want to do is I want to look at that value in the third position, 8, and I want to weight it a little bit more than that value in the second position, which is -7. So what are my weights? How am I going to come up with these weights? Whatever position that formula tells you, your percentile you're interested in, you're going to take that decimal and use it as your first weight. And then whatever would get you up to 1 will be your second weight. So here, 2.75, 0.75 will be my first weight. 0.25 will be my second weight. If it was, 2.3, 0.3 and 0.7 would be my weights. Is that clear? Any questions on what I'm kind of saying there? So you use whatever that decimal is as your first weight, and then whatever would kind of get you up to 1, right, as your second weight. So now I've got my two weights. I didn't give myself very much room, so I'm going to write it down here. I'll take that first weight of 0.75, and I'm closer, right? 2.75 gets closer to the third position. So I look at the value in the third position, which is 8.09, and I multiply that by the first weight. So 0.75 times 8.09, and I'll add to that, right? Use my second weight and take the value in the second position, right? I was in between the second and third position, but a little bit closer to the third. So I'll take that -7.34, and that one gets weighted by the smaller weight, right? Because I'm further away from that position. Now, you can kind of notice like weight times next value, plus the next observation is weight times x value. It's kind of like what we're doing with the weighted mean. That's essentially the exact same thing. But what about the sum of my weights? Well, one thing that's kind of nice with interpolation, right? What would the sum of my weights be here? 0.75 plus 0.25. I said we choose the weight, the second weight by whatever gets us up to 1. So we know that these will always add up to 1. If I'm dividing anything by 1, nothing changes. So I essentially can ignore it, right? I only kind of have to worry about what's in that numerator. So I think I have this up here, right? We do that math, we end up with 4.23, which makes sense, right? I knew I was in between the second and third position, so somewhere in between -7 and 8, but 2.75 was a little bit closer to the third position. So the value that's actually the 25th percentile would be a little bit closer to 8 than it would be to -7. Questions on this? All right. there's no questions, right? I'm gonna have you guys work through one. Kind of give you probably 3 or 4 minutes to work on this, work with the people around you. And then we'll kind of answer whichever one of these you think is correct, and then we'll kind of come together and talk about it, okay? Think about what you're trying to find. So you're trying to find the metal fund value that's in the 75th percentile. We just worked through one where we did the 25th percentile. Okay? Maybe you kind of help remember. First, you would arrange the data. Well, I did that for you, so you're welcome, right? But then we use this formula, right, to find the position that would give us that 75th percentile. Right? So we're interested in P, that 75th percentile. Once I have that position, it'll probably be a non-integer. So I'll probably be in between two, right? Kind of like we were before, we were in between the second and third position. And use whatever value you come up with here to determine what your two weights are. Then weight the value of the position that you're closest to with the higher weight, and then the value that you're further from. Sorry, the position that you're further from with the lower weight. Like I said, feel free to talk to those around you, kind of work. It doesn't have to be super quiet. Yeah. So you see the second, third position with that? Those are the two values. So the value we can look before is 2.75. So we're at 2.7. 2.7. But in between, second. Yeah. Yep. Give you about another minute. We'll kind of stop at the 4-minute mark up there. All right, if you haven't gotten an answer in, take your best guess of these values now. Missing 3 people today. All right, I'm gonna close it out. 38 of us here, only missing 2 people, that's not bad. So, first step was done, data's from smallest to largest. So what's the next step here? We have to use this formula to find the position we want. So you guys already did the work, and I'm not going to be able to do all this in my head, so I'm going to need a little bit of help. But nice thing is, I didn't change n. Gave you the same data set, right? So we've got 10 observations here, 10 positions. I want the 75th percentile. Right? So I plug 75 in there. So what position does that give me? 8.25. I was going to say nobody got it. So 8.25. So we're in between what two positions? 8 and 9. So we know the value that gives us 75th percentile is somewhere in between what? 43 and 59. However, we're a little bit closer to that 8th position, so the value should be a little bit closer to 43 than it is to 59, right? So if I'm thinking about the value, it's probably, I'm just looking at this, somewhere maybe a little bit below 50 would be my guess. If I had to throw a dart up here, you know, I would probably guess 47, but it could be 51. That's a little bit closer to, wait, is it? It's a little bit closer to 43.7 is to 59. But I want to come up with the exact value and not just take a wild guess at this point. What are my weights going to be? Yeah, look at the decimal, 0.25. My second weight is going to be 0.75. Same two weights we had before. It's just now I have to be a little bit careful. When I have something that's below 0.5, it's not that I just take 0.25 and multiply it by, you know, that 8th position. I have to think at this point, this is, you know, I get my weights. Now I have to think, well, which one would get the heavier weight? Well, it's the position I'm closer to. So I'm a little bit closer to the 8th position. So that value of 43 should be multiplied by that higher weight, that 0.75. So 43.79. And then we'll use that smaller weight and we'll multiply the position that we're further from, that 9th position. So 59.45 is in that 9th position. We'll multiply that by the smaller weight of 0.25. So, right? And we should be done. So what is it? I actually don't know what the answer is. 47, right? Yeah. Thought so. So I don't know what it is. I can kind of conceptually think about what it was. I just didn't want to look like too much of an idiot. 51 would be a possible answer. However, 55 here didn't make any sense. Yes, it was in between the values in the 8th and 9th position, but 55 is closer to that value in the 9th position than the 8th, which we know shouldn't be the case. The position we want is 8.25, so a little bit closer to that 8th position. And then, hell, -3 doesn't make any sense. Right? I was going to pop up and look at the answers, but if someone put -3, I don't want to. Yeah.
So if it was, this makes sense. So if it was 8.75 for the first one that we got,
yep.
You would multiply 0.75 times 59.45.
If this was 8.75, all that would change is I take that higher weight and I multiply it by the position I'm closer to, 8.75, I'm closer to the 9th position. So yes, you're correct. If this was 8.75, you would have taken 0.75 multiplied by 59, 0.25 multiplied by 43. Yeah.
What is an easy way to remember this so we don't flip early?
Yeah, so that's where there's really no, how to remember it is really to remember the concept of what you're doing with interpolation. You know that you're in between two values, but you know you're not smack dab in the middle. So whichever one you're closer to. So if I look at this position that I want, whatever position it's closer to, that's the value that gets multiplied by the higher weight. So let's say I came up with, let's say it was like 5.6, right? So my weights would be 0.6 and 0.4. And because I'm closer to the 6th position, that 0.6 I would multiply by the position I'm closer to. So I take the value in the 6th position, and that would get multiplied by the higher weight. So you look at this position to determine what value I should be closer to. And then that's the value that you multiply by the higher weight. Any other questions, comments, concerns? Okay. So here's just kind of like the work, kind of what I did in the board, but a little not as complete in the slide here. So one more thing we'll talk about when we leave today. Once we calculate these percentiles, we can come up with these things called interquartile ranges. So That's why I was kind of typically using like the 25th, the 75th percentile. Those are what we call the first and third quartile, right? Whatever value is in the 25th percentile, whatever value is in that 75th percentile, we call that the kind of first and third quartile. And then the second quartile is simply the median, right? The 50th percentile we've already talked about. The 50th percentile, I mean, this is the value that's greater than 50% of the data and less than 50% of the data. Well, that's literally the definition of the median. So we can use these percentiles to do something we call a box and whisker plot. Might have seen these, I don't know, I think science classes like to use these a lot. So that doesn't make sense. I'm looking at it backwards. So what we'll do is we'll first create this box, right? And we'll use that kind of first and third quartile to set those values. So I don't know, let's say this was something like 40 and 60. I would then draw a line wherever the median for that second quartile is, let's say 45. So that kind of gives me my box. And then to come up with the whiskers, right? We'll create these upper and lower limits by taking up something we call the interquartile range, which is just the difference between the first and third quartile. So here my interquartile range would be what? 60 minus 40. I then use that value and simply plug them into these pretty easy equations where I'll take the first quartile and I'll subtract 1.5 times the interquartile range. So here, to get the lower limit, I'll take that first quartile minus 1.5 times the interquartile range. Any questions on that? Not too bad. So that value would be what? 30, 40 minus 30. So we get that lower limit of 10. Kind of draw what we, the whisker here, just a line down a little tick. And then do the same thing to get my upper limit. However, that's going to be what? Take my third quartile and add 1.5 times my interquartile range. So 60 plus 30, I get an upper limit of 90. But you'll see these, I think, you'll see these a lot in like academic papers. A lot of people like to use them to kind of show distributions of data. I think there's a much better ways, but I haven't mentioned because you might see this in some of your other classes. I probably won't have you ever create one of these, but I just want you to be aware of how they are created. And it's basically using percentiles. Yeah.
Always added by 1.5.
Yep. So what this is basically now that I have this box and whisker plot, if I have data, and let's say I had an observation that was like 105, any data point past these whiskers, these upper and lower limits, I can classify as an outlier, and this actually justifies me not including them in my statistic. Like I can throw it out as a data set. Because I'm saying, look, so much of the data is in the middle here, that even if I create these extreme kind of boundaries, this data point's still outside that boundary. Something weird must be going on. I don't want it to skew my statistics. So what we call this is the Q test, right? And if you have a data point outside this range, you can call it an outlier and get rid of it. So please don't reject it as an outlier because you're the Q test, right? So, I mean, you might see this in other classes. It's all based off of calculating percentiles, which that's kind of what I'm more focused on. All right. So if you guys have any questions over the next couple of days, make sure you reach out. I want you all to do well on those first couple of homework assignments. Look for that additional quiz. It's not worth any points, just some practice. All right, I'll see you guys on Friday.